Before we dive into the statement, it's far more persuasive to sort out what molecular gasoline pedals are. The Big Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets. In addition, it's the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could reproduce the precise states of the first moments on Earth. But could the system intended to unlock the mysteries of the universe hold the key to something truly specific? Founded in 1954, CERN is one of the world's most famous research institutions with 23 member states and countless researchers. It's a place for collaboration and innovation. The LHC is CERN's principal undertaking, but it is only one part of a larger network of accelerators and experiments. Consider a route not for automobiles or people, but for subatomic debris. In a trial of aptitude, patience, and space itself, the LHC accelerates protons to almost the speed of light, sending them on a collision course that mirrors the energy of the universe right after the Big Bang. The impacts create temperatures much hotter than the core of the Sun. A vast number of magnets guide the protons on their journey, while complex cooling structures keep the magnets at temperatures colder than space. The beams in the LHC are made to crash at 4 locations around the accelerator ring, interacting with 4 particle detectors: Atlas, CMS Alice, and LHCb. Each serves a specific purpose, investigating different components of particle physics. Together they act as enormous cameras capturing images of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building blocks. By focusing on the microcosm, we gain insights into the universe. But with every solution comes another question. With every discovery, another challenge emerges. The LHC is not just a scientific instrument, it's an exhibition of human curiosity and progress. It represents our unrelenting mission for knowledge and our desire to understand the key forces that shape our universe. But as we push the limits of what we know, we must also consider the more profound and existential questions that arise. Within the sacred halls of CERN, where the boundaries of human knowledge are constantly pushed, a revelation has arisen, one that sends a shiver down the spine of even the most pro-science individuals. Brian Cox, a former scientist at CERN and a leading voice in the field of particle physics, has recently made a statement that has left the world both enthralled and uneasy. Cox's words resound with chilling clarity. The physicist went on to explain the ramifications of this aim, highlighting the LHC's immense potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a vast portion of the universe. Imagine holding the power of creation in your hands, the capacity to summon the very essence of the universe. It's an alluring possibility, but one fraught with danger. The mini Big Bang isn't just a theoretical idea, it's a very real phenomenon within the LHC. The temperatures, the pressures, the raw energy, everything recreates the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of life itself. Russian physicist Anatoly Bugorsky encountered a disaster that would forever change his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a failure caused his head to accidentally enter the direct path of a proton beam. The beam, with a force that defies perception, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was harrowing. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path left a trail of destruction, burning tissue and bone, but he remained conscious and even walked to the medical center for treatment. The outcome was both troubling and remarkable. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a reminder of the immense power and potential dangers of particle accelerators. The dangers of a particle collider like the LHC are not to be underestimated. The potential for catastrophic reactions, the very fabric of existence being altered, these are not the stuff of science fiction but real concerns voiced by respected scientists. One of the most unsettling and captivating concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, and mysterious entities lurking in the shadows of our universe. The fact that the LHC could potentially create such a phenomenon, even on a small scale, is awe-inspiring to both the public and scientists alike. Scientists at CERN have reassured the public that any black hole created would be unstable and disappear very quickly. Nonetheless, the remote possibility has sparked debates, fears, and a sense of awe at the energy we wield. It's important to understand how the LHC might create a black hole. It all comes down to the basic mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight, then a heavy object dropped onto it. The material bends, and if the object is heavy enough, it could create a well so deep that anything nearby could be drawn into it. In the realm of quantum physics, where the laws of the universe are both strange and wondrous, there's speculation that extra dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This peculiar dance of particles has even caught the attention of some respected scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario in which the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic event known as vacuum decay, an event that wouldn't just destroy Earth but could potentially annihilate the entire universe. The renowned English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the potential dangers of high-energy physics experiments, including those at CERN. He examined a worst-case scenario in which a failed experiment could trigger a phase transition that would ripple through the fabric of spacetime, resulting in a disaster that would engulf the entire universe. The Large Hadron Collider, LHC, remains an awe-inspiring symbol of human ingenuity and the relentless pursuit of knowledge. Yet, as we move forward in this scientific odyssey, the next frontier of particle physics is already on the horizon. CERN has ambitious plans to upgrade the LHC, pushing its capabilities even further to unlock deeper cosmic mysteries. The High-Luminosity Large Hadron Collider, HLLHC, is the next major upgrade planned for CERN's flagship accelerator. Set to be operational by the mid-2030s, this upgraded version will significantly increase the number of particle collisions, improving the probability of discovering rare phenomena. The HLLHC will provide 10 times more data than the current LHC, allowing scientists to probe even more deeply into the mysteries of the universe. By enhancing the power of the LHC, researchers hope to study the Higgs boson with greater precision, search for new particles beyond the standard model, and investigate whether the forces of nature behave differently at extremely high energy scales. If successful, this could lead to the discovery of entirely new physics, potentially revealing hidden aspects of reality that were previously inaccessible. Beyond the HLLHC, CERN is already envisioning an even more powerful machine, the Future Circular Collider, FCC. The FCC would dwarf the LHC in size and capability, boasting a circumference of 100 kilometers, 62 miles, and energy levels nearly 10 times higher than those achieved by the LHC. With such a machine, scientists could explore physics at an unprecedented scale, potentially discovering new forces of nature, probing the existence of extra dimensions, and even resolving the mystery of dark matter. However, such an endeavor comes with immense technical and financial challenges. Constructing the FCC would require decades of research, international collaboration, and significant advancements in superconducting magnet technology. Yet, if realized, it could redefine our understanding of the universe and lead to discoveries as groundbreaking as the Higgs boson. As the LHC and its successors continue to push scientific boundaries, they also raise ethical and philosophical questions about humanity's role in shaping the universe. The ability to recreate the conditions of the Big Bang, manipulate fundamental forces, and probe the deepest layers of reality brings both promise and peril. Some argue that pursuing high-energy physics at such an extreme level requires careful ethical considerations, ensuring that scientific progress does not come at the cost of unforeseen existential risks. Others contend that humanity's insatiable curiosity and drive for discovery are intrinsic to our evolution, and that we must continue to explore the unknown despite the uncertainties. Moreover, as theoretical physicists like Stephen Hawking and Martin Rees have cautioned, even the smallest probability of catastrophic events such as vacuum decay or an unintended alteration of spacetime demands scrutiny. While the consensus remains that such outcomes are highly improbable, the mere contemplation of such scenarios adds a layer of existential weight to the LHC's endeavors.